Hello everyone, how are you today? You are welcome back to class. This week we are looking at sound wave or sound energy. Okay? Well, when you talk about sound, we are talking about energy that is transmitted as a result of vibration. But for us, we want to look at how that energy is being, traveled from the source of vibration through air. Now, I need to remind you, in our, I think like 2 weeks back, when we were talking about waves, I told you about compression and rarefaction. If you remember, I said when sound wave is traveling, when it's moving, particles, we have regions. We have places where particles are very close together. Those we refer to as compression. We have regions where the particles spread, region where they spread apart. We call those regions rarefaction. Okay, don't forget that's part of what we should consider in this topic. Now, when you talk about when sound is being traveled, because sound is a wave, we need to realize that everything you know about waves is also applicable. But in addition to what you know in waves, I want to quickly point you to what we refer to as frequency, amplitude, and out of the board, these simple diagrams that will give you a brief hint into that have for pitch. When you talk about pitch, frequency of a wave determines pitch. And what are the types of sound that we say? High pitch sound are those sounds like when you scream. When you scream, I'm sure you don't want to stay around something that screams. Such sound has high pitch, and this one has many waves. If you count the number of waves for this first one, we can see 1, 2, 3, 4, 5. I have 5 waves here, and the second one we have 2 waves. So the higher the frequency of a wave, the higher the pitch. The ones that have smaller number of waves, it has low pitch. Alright? So that's about pitch sound. For loudness, when we have a wave, we have what we call amplitude. Amplitude is the maximum displacement from the rest line. And if you see the one I have on my left hand side, the amplitude of this is greater. You can see it's twice the one that we have on the right hand side. So this sound is louder than the second one, right? So you need to remember amplitude determines loudness and frequency determines pitch. Another thing we need to quickly talk about is how do I determine the speed of sound in here? Well, for us, the value before this time, people have done the experiment. The value is actually between 300 and 330 meter per second. That's the rate of value of speed of sound in here. But how do you determine this in an experiment? Because you should know how to describe this. What you do is you look for a source of sound. Your source of sound could be a bell. It could be a whistle, whatever, or it could be a clap. Okay, you have a source of sound. You be in a place where you have a hard surface, a barrier that the sound can actually be reflected. And don't forget, this must be in an enclosed place where there is no interference sound from outside. So what we do is, and don't forget also that sound has ability to reflect. Okay, so when the sound is being produced, you make the sound. You start your timer, stopwatch. You wait for the time for you to hear the sound once again. Okay, meaning that the sound is being reflected. That reflection what we refer to as echo. All right. So once the sound comes back to you, we believe that the sound must have traveled distance from the source to the barrier and come back, meaning that distance will be 2D. So the time it took the sound to travel from the source and back to you is T. Therefore, the speed of sound is calculated using 2D divided by T. Don't forget the same unit that we use for speed. If your distance is in meters, your time is in seconds, of course your answer is going to be meter per second. Like I told you, this has been done. We have constant values. It always is between 300 and 330 meter per second. Let me also quickly remind you, the rate at which sound travels in solid, liquid, and in air varies. Sound travels fastest in solid, followed by liquid, and of course, sound, the lowest, its lowest speed is in air. And you can relate that to the particles. In solid, the particles are they are compact, they are very close to each other. So once one vibrates, it gives the energy to the next one. So that's why the sound travels faster in solid. And because in liquid, the particles are relatively further from each other. So the speed is not as much as in solid, and the least is in air. So thank you so much. So we'll see you next week. I wish you all the best, and I will be happy to hear from you. Bye for now.